Welcome to e-learning session. Myself Santanu Pathak, lecturer in food processing technology. Today we will discuss on unit operation of chemical engineering 1. In this session we will discuss about basics of thermodynamics. First of all, we should know what is thermodynamics. It is a combination of two words, that is thermo and dynamics. Thermo means heat and dynamics means change. That means here in this session we will discuss about the change of heat during any physical or chemical reaction. Most of this course will be concerned with understanding the pattern of energy change. More specifically, thermodynamics will deal on energy conversion and the direction of change of energy. The relation here we will learn the relation between different macroscopic properties or system can be determined by thermodynamics. Interrelation between different types of energy, maximum efficiency of a heat engine under certain condition, can comment on the probability of the extent of reaction, that it may be physical or chemical. So these are the things we will learn after completion of this particular curriculum. Thermodynamics consists of four main laws, that is zeroth law of thermodynamics, which will deal about the temperature, first law of thermodynamics, which will deal about the internal energy, second law of thermodynamics, that is basically on the entropy, that is S, and third law of thermodynamics, that will give us numerical value to entropy. So these are the four laws which we have to understand. In our curriculum, third law is not there. We will discuss only zeroth law, first law and second law. These laws are universally valid and they cannot be circumvented. Now we will gradually move to the thermodynamic terminologies. So many terminologies are there, systems, properties, processes are there. We will understand one by one before going to the main topic. Thermodynamic system, first, what is system? System means the part of the universe in which we are interested. That means suppose you are doing some experiment. So that particular conical flux or beaker, that is the system. Apart from that particular conical flux or the beaker, whatever is there in this world or universe, that is called surroundings. That means universe, it consists of system and surroundings. So we can write system plus surroundings equals to universe. And the barrier, the surface dividing system from the surroundings, that is called boundary. You should know clearly what is system, what is surroundings, what is boundary. Again, I am repeating, system means the part of the universe in which we are interested, that is called system. Apart from the system, whatever is there in this universe, that is called surroundings. And the imaginary boundary line, imaginary surface that divides the system from the surroundings, that is called boundary. Here you can clearly understand that system is inside the confined surface and the dotted line indicates the boundary, and apart from that system and boundary, whatever is there, that is called surroundings. So we can write system plus surroundings equals to universe. Systems can, now we have to understand, we have to know how many types of systems are there. Systems, it can be classified into three categories: open system, closed system and isolated system. Open system means where mass and energy both can be transferred from system to surrounding. That means there will be interexchange of mass and energy between system and surrounding. That is open system. Example, suppose you are boiling a cup of water. Sorry, you are boiling water in an open can. So what will happen? Energy and mass both will go to the surroundings. That means energy and mass both can be transferred. Closed system where energy can be transferred but mass cannot be. Isolated system, neither mass nor energy can be transferred from system to surroundings. Example of closed system, suppose we are boiling water in a closed vessel. What will happen? Energy can be transferred but mass cannot be. So that is closed system. Isolated system, that is thermoflux. That means thick wall, isolated wall is there where energy cannot be transferred as well as mass cannot be transferred. So we need to understand the examples also for the system, open system, closed system, and isolated systems. Okay. Now we will go to the properties. Here in this particular topic, there are two type of properties, that is macroscopic properties and microscopic properties. Macroscopic properties means that can be measurable, like temperature, pressure, volume, etc. These are macroscopic properties. In our thermodynamics, classical thermodynamics, it is mainly applicable for the macroscopic system. Okay. A few macroscopic properties already I have discussed: pressure, temperature, volume, mole number, mass. These are the macroscopic properties. To have a thorough knowledge, you should know what is homogeneous system, what is heterogeneous system. Knowledge is required for different types of equilibriums. Knowledge is required for number of components. You should know what are the components. Now we will discuss about control volume. Control volume is very important. Control volume is defined as a volume which encloses the matter and the device inside a control surface. Suppose you have considered a piston cylinder having a piston. The piston is frictionless, weightless, and it can move up and downwards. So whatever the area enclosed by the piston and the vessel, that is called volume. Volume, that control volume can be increased or decreased by moving the pistons. The boundaries may be movable or stationary, what I have already told. In case of control surface that is close to the mass flow, so that no mass can enter or escape the control volume, it is called control mass, containing some amount of matter at all times. There must be some matter. Without having matter, we will not get the volume. Basically, in this chapter, we will discuss about the closed system. We will not discuss about the open system or isolated system. So, all whatever theories we will discuss in this particular chapter, it will be for the closed system. Now, the question is there about the equilibrium. What is equilibrium? Equilibrium means when the property of a system is defined, it is understood that the system is in equilibrium. Equilibrium means there is no unbalanced component. Equilibrium can be three types, that is mechanical equilibrium, chemical equilibrium, and thermal equilibrium. Mechanical equilibrium means whenever you have put a system, there should not be any unbalanced force. That means it will be in a balanced form. Chemical equilibrium means there will be no conversion. Apparently, there will be no conversion. That means rate of reaction for the forward reaction will be same for the backward reaction. Apparently, it seems that there is no reaction. So that is called chemical equilibrium. Thermal equilibrium means there is a equilibrium between two bodies or two systems. So in this chapter, we will discuss only about the thermal equilibrium. Chemical equilibrium and mechanical equilibriums will not be discussed here. Before going to the main topic, we should know about the basic units in SI which are required for the thermodynamics problems and theories. All of us are aware about these units, but still you should know. That's why I put a slide here. Mass, what is the unit of mass? That is kg. What is the unit of mole? The mole. Length, meter, time, unit of time. All of us are aware. That is second. And temperature, unit of temperature is very important. We know degree centigrade, degree Fahrenheit, but here all the temperature will be calculated in terms of Kelvin. These are the direct units. Few derived units are there. That is force means Newton, pressure means Pascal. So these are the different types of units which will be required for this particular topic. Now we will discuss about thermodynamics functions. Thermodynamic functions can be two types, that is state function and path function. State function means state 1, we have taken the system from state 1 to state 2. So the values will be changed. If the change of the property is dependent upon the path, then that type of function is known as path function. And the property, if the property is independent of the path, then that is called state function. Now we'll try to understand what is state function and path function. Basically, state function is a property whose value does not depend on the path taken to reach that specific value. That means temperature. Suppose state 1 to state 2, we have taken some system. the temperature of state 1, that is T1, and the temperature of state 2, that is T2. So you may follow n number of paths, but the initial and final temperature is independent of the path. So whatever path you follow, the final state temperature will not change. That means temperature is, at state 2 and temperature at state 1, that is fixed. So that change is independent of the path. This type of function is known as state function. Whereas for different paths, work done will be different, heat transfer will be different. So heat transfer and work done, these are path functions. Both state and path functions are often encountered in thermodynamics. Now come to the properties, intrinsic and extrinsic properties of thermodynamics. What is intrinsic properties? Intrinsic properties are those which are dependent on the quantity of mass. That means if the quantity of mass is more, enthalpy will be more. Quantity of mass is more, then internal energy will be more. That means these properties are dependent upon the mass. So properties which are dependent upon the mass, that is called extrinsic property. Properties which are independent of mass, that is called intrinsic properties. Example, simple example, length. The length of a piece of wire depends how much wire you have. That means length is extrinsic property. If you take 1 meter wire, mass will be more. If you take 50 centimeter wire, mass will be less. But you take 1 liter water, temperature will be T1. If you take 2 liter water, temperature will be T1. That means temperature is independent of the mass. So this is intrinsic property. Gradually, we will discuss so many important parameters which are generally used in thermodynamics. We need to classify them, change of those properties, whether those are state function, path function, and the character is intrinsic or extrinsic. We will make a list and we will discuss these things later also, whether proceeding further. Okay. Now we should know several processes which are there in thermodynamics. There is a brief listing of few kind of process. Apart from this process, so many processes are also there. Will discuss one by one about them whenever it is required. So these are the main processes which are there in thermodynamics. First, isothermal process. Thermodynamics means we need to change the state of the matter. Isothermal process is when a process takes place at constant temperature. Means when you move to state 1 to state 2, throughout the system, throughout the process, temperature will be constant. That means del T will be 0. That example, freezing at water to ice at minus 10 degrees C. So their temperature will be constant. Whenever there is a phase change, temperature will be constant. That means that is isothermal process. Isobaric process, where pressure is constant, del P equals to 0. Isochoric process means volume is constant. That means del V equals to 0. Cyclic process means whenever you start from a point, after two or three stages, again you are coming back to the main point, means initial point. That process is called cyclic process. That means the final and initial states are same. However, Q and W need not to be 0 in this case. Adiabatic process means there is no exchange of heat between system and surrounding. That means dQ is equals to 0. Reversible process, the system is close to equilibrium all the times to the original state. That means whenever there is a change of state, means state 1 to state 2, it consists of a number of infinitesimal small steps, and by changing the external pressure very slightly, again we can come back to the initial state. So that is called reversible process. Irreversible process means sudden change in pressure and there is a change of state from state 1 to state 2, and it cannot be brought again to the initial state by changing the external behavior. That is called irreversible process. So generally in universe, no reaction or no application is irreversible process. All are irreversible process. That means irreversible process are spontaneous. We will discuss these things again in our thermodynamics law discussion. A combination of the above processes are also possible. That is reversible adiabatic process, irreversible adiabatic process. We need to know work done for all the stages. Now, already we have discussed about the thermodynamics process. Now we should know about a little bit about temperature. All of us are aware about the temperature. Though we will have a feel of temperature in the context of thermodynamic, temperature is a technical term with deep meaning. Deep meaning means everything is dependent upon the temperature. So temperature can be measured at Kelvin. The unit of measurement of temperature is Kelvin. Here we will not use the degree centigrade or degree Fahrenheit. Temperature. So everything is written here. You can just go through this thing. Now we should know what is pressure. Pressure is the nothing but force per unit area easily exerted by fluid on a wall. Force per unit area. Pressure means force exerted by a fluid on a wall. It is basically the momentum transfer per unit area per unit time. Pressure is also related to momentum, while temperature is related to kinetic energy. See, here I have tried to show some figures how pressure is exerted. This is the wall, and these are the molecules of the fluid. Again, fluid means, don't think fluid means only liquid. Fluid means which can flow. So, if you categorize fluid, it can be classified into two groups, that is liquid plus gas. So, here in this particular chapter, we will discuss about the properties of gas. Now we should know what is heat capacity. It is very important. Heat capacity. Heat capacity is nothing but the amount of heat required to raise the temperature by 1 degree C or 1 Kelvin. Generally, it is measured in joule or calorie. As mentioned before, bodies contains internal energy and not heat. This heating can be carried out at constant volume or at constant pressure. At constant pressure, some of the heat supplies goes into doing work of expansion and less is available with the system. That is to raise the temperature. That means whenever you are supplying heat to a system, one person goes for the work done and another person will go to the increase the internal energy in terms of heat. Heat capacity. Now we should know what are the types of heat capacity, that is Cp and Cv. Heat capacity at constant volume, that is designated by Cv. It is the slope of the plot internal energy with temperature. It can be determined or it can be concluded as Cv equals to del T at constant volume. Same thing. We will discuss these things after discussion of first law again. Here I am summarize all the terminologies which are important for the understanding of thermodynamics. That's why I have shown the heat capacity in the very beginning of the chapter. Don't worry, we will understand these things again. Heat capacity at constant pressure, that is Cp. It is the slope of plot of enthalpy with temperature. It can be determined as Cp equals to del H, del T at constant pressure. Here, del E means change in internal energy, del H means change in enthalpy. Already so far we have not discussed about the internal energy and enthalpy. This will come later also. Just have an idea for the time being, and we will discuss this thing later also. Units: joule per Kelvin per mole, joule per Kelvin per mole. Heat capacity is an extensive property. That means dependent upon mass. If a substance has higher heat capacity, then more heat has to be added to raise the temperature. Water with a high heat capacity heats up slowly as compared to air. This implies that oceans will heat up slowly as compared to the atmosphere. So these are the basic terminologies which are used for understanding of thermodynamics. So as of now, I would like to close this session here. From the next lecture, we will start from the zeroth law of thermodynamics, first law of thermodynamics. Thank you. If you have any query, you can email me at sp.fpt.arm@wbsct.ac.in. Thank you.